a styrofoam block, and all we have to do, now you're not going to get the 100 to 150,000 volts that we get on a vending rack, but you will be able to get a charge. We can demonstrate that with our little pit ball, PITH. You can get a charge. This is lamb's wool. I know me because my daughter raised a lamb and cut this piece off. And we can put a charge. Remember what we said. Some things give up electrons easily. This gives up electrons to the styrofoam block. We put the, did anybody hear that little spark? Good. That means this is charged. It happens to be charged with a positive charge. We'll explain that. But what happened? Oh, look at that. We've got an electric field on this electrolysis. And you can come up with all sorts of experiments that you can do with a simple device like this. One of them is to take a straw, bendable straws, and attach a pit ball to it, and then tape the other end of the straw to a aluminum can, or a steel can, a tin can as you call it, and you can make this into an electronic current. If we had a little can, it would be attracted, get charged, it will go to the aluminum can, it will get discharged on the aluminum can, and it will bounce back and forth very nicely as we were doing with the sphere. Notice we still have a charge on that sphere. So that's an electrolysis, and I think we're 3 minutes away from finishing. And my voice is running down. Somebody's got a last minute question. Oh, one thing that I'm surprised you haven't asked. What do you do with an electrostatic generator like this? What can you do with it? Does it have a practical use other than to demonstrate to students about electricity, about static electricity? I told you I worked for Van de Graaff. At that time, in 1948 and 1952, the 4 years I worked there, what we were doing was building Van de Graaff generators, which was the best source of a constant voltage, because as long as you don't pull a spark off, it maintains a constant potential. You can use that to get an electron flowing down a vacuum tube, striking a gold target, and put in your memory banks. What you get when you strike the gold target with an electron is X-ray. And this was in the early days of treatment of cancer with very accurately focused X-rays. They could adjust that voltage, particularly the voltage they wanted, to get a constant source of X-ray. What they have been using up to that, and they use even today, is alternating current, which gives you a varying voltage. It varies sinusoidally, and so you don't have the precise focus. You have a question or a comment?
What happens if you put something inside those two spheres and then you turn it on?
Try and question again.
What if you put something inside the two spheres and you turn it on?
If I put something,
yeah,
there's no field inside the sphere. Practically, no. There's a very, very low field. It's the same thing as if you're in an electric store and you want to be safe, stay inside your car, because inside your car you have no electric field. Practically done. Any other questions?
What happens if you try to magnet the string?
Can't hear you.
What happens if you put a magnet
Boy, I wish I almost brought with me a demonstration that shows the link between magnetism and electricity. because there is a very definite link. The field on this sphere is at right angles to the sphere. The magnetic field, which you can't see and it's hard to demonstrate it, is actually concentric spheres that go outward, at least as far as the electric field goes. So they are orthogonal to each other. The magnetic field is at right angles at all times to the electric field. But they are closely linked. And at some point, I hope you're going to get a chance to see that. I don't know if they study.
Yeah, we've done electromagnetism.
You have.
Electricity and magnetism.
Yeah.
The connection.
So you've actually made a magnet with electricity flowing.
Electromagnetism.
And the electrons that are flowing in the wire are at right angles to the polarity of the magnet. So they're always orthogonal.
Oh, nice.
All the way over there. This is best to do with the electrons because you can walk around with the Well, we have another field that's kind of disturbing. We'll get rid of that. I used to do these classes with a buddy who he was good at this. Well, we may have lost the charge here somewhere. There we go. Subtract it. Once it gets charged, it should.
You know what, it is metallicized plastic, so that's
Yeah,
what
this
happening.
metallized plastic. Which
But it does
nothing.
work
If you get
after a little while.
If you get some real old-fashioned tinsel of the Christmas tree, it's a good conductor. This is a semiconductor. It's usually mylar, that's metallized. And so it has a winding remote. But you can see that it's attractive. And hopefully, if I wipe that over there, it will pick up the same charge. And, this is metallized plastic. We can always do it with this. What do you think will happen when I turn the Van de Graaff?